Assalamu alaikum. Today in this lecture we will review the thermodynamic laws and we will give some examples. Okay. Uh, the first zero law of thermodynamics state that when we have two objects, object 1 and we have another object, object 2, are separately in thermodynamic equilibrium. With third object, they are in equilibrium with each other. This is the zero law of thermodynamic state about the equilibrium of temperature. So object in thermodynamic equilibrium have the same temperature. This means object 1, object 2, and object 3 are the same temperature. The first law of thermodynamic state about the conservation of energy. And this is the delta U equal heat plus the work or minus the work. It depends if it's depend on the state of the work. And there is a process, some process terminology. It's a diabatic process. This means that no heat exchange or no heat transfer. Isothermal, this means constant temperature. Isobaric is constant pressure. And isochoric or isovolumetric, this means constant volume. Work done by gas at constant pressure, the work is equal the pressure multiplied by the change of the volume. This is at constant pressure. Also, we talk about the heat capacity. Heat capacity is the amount of heat required to arise a certain mass of material by a certain temperature is called heat capacity. And this heat capacity Q equal M في Cx في delta T. The constant Cx is called the specific heat of substance X. Then there is different heat capacity for different material. And the unit of the heat capacity, specific heat capacity, is joule لكل kilogram Kelvin. Heat capacity of ideal gas. There is a heat capacity at constant volume and for ideal gas CV تساوي 3 على 2 مضروب في R. And heat capacity at constant pressure CP equal 5 على 2 مضروبة في R. And for constant volume Q بتساوي N في CV في delta T. And this is equal delta U, the internal energy, the change of internal energy. And the universal gas constant R, which equal 8.314 جول لكل مول كلفن. Also, we talk about the heat engine. Heat engine change heat into useful work. Needs temperature difference. إذا لازم يكون عندنا درجات حرارة مختلفة. Efficiency of heat engine. The efficiency is equal the work divided by the heat at high temperature or hot. So the efficiency equal the work over QH and the work equal QH minus Q low or cold. أحيانا بعض الكتب تستخدم L low temperature و high temperature. and بعض الكتب بتستخدم اللي هي cold reservoir اللي هي QC. so it's the same over QH. إذا the efficiency equal 1 minus QL or QC over QH. The upper limit on efficiency for the Carnot ideal efficiency equal TH minus TC or TL over TH وتساوي 1 minus T at cold reservoir over T at hot reservoir. Refrigerators and air conditioning do work to extract heat from a cooler region and send it to warmer region. إذا COP تساوي QC over the work or QL over the work. Refrigerator and air condition. This is for COP, coefficient of performance. A heat pump is similar. لكن for heat pump which equal QH over the work. This is for heat pump. Q at heat reservoir O divided by the work. In second law of thermodynamic, heat flows spontaneously from a hot object to a cold one, but not reverse. إذن the second law of thermodynamic إنه الهيت flow spontaneously from hot object to cold one، لكن وليس العكس صحيح. ليس from cold to hot. A given amount of heat cannot be changed entry to work. Natural process tends to increase the entropy. So the change in entropy delta S equal Q over T. And the entropy is measure of disorder. Okay, we have some example about the conceptual problems. Modern automobile gasoline engine have efficiencies of about 25%. About what percentage of heat of combustion is not used for work, but released as heat? Okay, 25% B, 50% C, 75% and D 100%, and E you cannot tell from data given. Okay, how to solve this problem? Determine the concept. The efficiency of heat engine is the ratio of the work done per cycle sorry, work to the heat absorbed from a high temperature reservoir QH. So the percentage of heat of combustion, heat absorbed from a high temperature reservoir, is the ratio of QC to QH. Then we can use the relationship between the work QH and the QC. So the work equal QH minus QC to find QC over QH. So, and QC to obtain, solving for QC over QH yield, QC over QH equal 1 minus efficiency. Substitute for efficiency to obtain QC over QH وتساوي 1 minus 0.25 وتساوي 0.75. إذا C اللي هي 75% is correct. إذا the answer here is 75%. Okay, another example. If heat engine does 100 kilojoule of work per cycle while releasing 400 kilojoule of heat, what is the efficiency? 20%, 25%, 80%, 400%, or you cannot tell from the data given. What is the concepts? The concept of this problem, the efficiency of heat engine is the ratio of the work done per cycle to heat absorbed from high temperature reservoir QH. So we can use the relationship between the work QH and QC. The work equal QH minus QC to express the efficiency of heat engine in terms of QC and the work. So use the definition of efficiency and the relationship between the work QH and QC to obtain the efficiency equal the work over QH and the work divided by QH now equal the work plus QC because the work equal QH minus QC now related we will use the relation between the work وتساوي واحد على واحد زائد QC over the work and substitute for QC and the work to obtain the efficiency equal واحد على واحد زائد 400 كيلو جول على 100 كيلو جول وتساوي 0.2. إذا the answer is A and 20%. Okay, another example. If the heat absorbed by heat engine is 600 kilojoule per cycle and it releases 480 kilojoule of heat each cycle, what is the efficiency? 20%, 80%, 100%, or you cannot tell from the data given. Okay, we'll start by the efficiency. And we have the work over QH, and the work equal QH minus QC over QH. وتساوي 1 minus QC over QH. إذن the efficiency equal, okay, how much QC realized؟ إذا QC 480 كيلو جول على 600 كيلو جول وتساوي 0.2. And in this case, the answer is A, and which equal 20%. Okay, this is some example of this in this lecture, and we will continue next lecture by more example, more problem about the thermodynamics laws. And thank you for your attention.